Hello, in this lesson we are going to do the multiplication of two vectors. Instead of the dot product, we are going to do cross product. And for the dot product, we know that application is work. So the force and the displacement times together give us the force on the direction of the displacement. Times it, then we have the work. And this is a scalar. And today what we are going to do is cross product. This one is not a scalar. And when we do the dot product, if we have the component vectors, for example, a1 x, y, z direction for the a, and b is x direction, y direction, z direction, the dot product is just a direction times x direction plus y direction times y direction plus z direction times z direction. So this is a formula for the dot product. And by using this, we could combine it with magnitude A, magnitude B, and find the angle. Or if we have the two magnitude, we have the angle, we can find the dot product. And in this lesson, we are going to do the cross product. And for the cross product of two vectors is a vector that is perpendicular to both. So it means if we have f and d, then the dot product will give us pointing out or inside the page. So it will be 3-dimension. And we use a right-hand rule to figure out the direction of the cross product. So what are you going to do is, so you just, this is F, this is D, then you just put your hand, rotate, your finger rotate from F to D, then your thumb direction, so this one will be go inside. We use a for this one to represent it's inside the page. This outside of page, just use this dot outside. Okay, so just wrap your finger from F to D. So your finger is wrapped this way, then your thumb will be inside to the page. That is the direction of the cross product. Now we are going to see, in order to find a vector perpendicular to two vectors, we start from here to see how we could find the formulas for the product, cross product. So this is find another vector that is perpendicular to A and also perpendicular to B. And that is possible cross product. So if perpendicular, then we know the dot product will be 0. So this is B times C equals 0. Then if A is A1, A2, A3, B is B1, B2, B3. And C will be C1, C2, C3. Or we could use a C, just write it as X, Y, Z. The reason why we put X, Y, Z, because they are going to be variable, it will be many combinations for that. Then we could write dot product A1 X plus A2 Y plus A3Z equals 0, then the C is perpendicular to A, then times with B, B1X plus B2Y plus B3Z equals 0. Then we use the elimination method. What we are going to have is we could times B1 to this one, A1 to this, to the whole equation to get rid of the x, then we are going to have A2 B1 minus A1 B2 y equals, move this to other side, is A1 B3 minus B1 A3 z. Then it's kind of, we do the cross multiply. So y over A1 B3 minus B1 A3 equals z. A2 B1 minus A2 A1 B2 A1 B2. And if we times it and get rid of the other variable and leave the x here, we are going to have x divided by the, so we times B1, we times B2 A2 here, then A1 B2 it will be A2 B3 minus A3 B2. So all of them equals, and if we let it equals k, a scale factor, then x, y, z is just k times each of them. And when k equals 1, we have the x, y, z. This is how they find the c. So the c equals k times A2 B3 minus A3 B2. You don't have to derive this formula. A3 B1 minus A1 B3, then A1 B2 minus A2 B1. So this is another way, okay? And the definition of cross product is just let the k equals 1. Then this is A2 B3 minus A3 B2, A3 B1 minus A1 B3. And look at this one, it's too complicated. The mathematician figure out another notation. So it's kind of the matrix. So A2 B2, the first one is just A1, A2, A3 on the top, B1, B2, B3 at bottom. And for the first one, it's just use this part. So A2, B2, A3, B3. And the operation for this one is cross times. This A2, B3 times minus A3, B2. That is our first x direction. And for the y direction, we just continue, put A1, B1 here, just move it to here. Then we have A3, B3, A1, B1. This is for the y direction. And for the z direction, so the z direction is here, is just the first part. A1, B1, A2, B2. So by doing this, it will be easier for you to memorize this formula. So this blue box is x, the red box is y, and the green box is for z. Okay? And later I will show you another way to memorize it. And where we are going to use it, the area of a parallelogram. So area of a parallelogram, if we draw it, so if one side is A, another side is B, then the height is A magnitude times theta give us height. and times the magnitude of B give our area. So this one, we just use a magnitude because area is a scalar. So this is where the application of the cross product. So by just times find the cross product, we find the magnitude, then we have the area. And the bottom part are some formulas you could use right away. So A cross multiply with B is this one. It's hard to memorize. Use this matrix. And I will show you another way to memorize it. And if is changing the direction. So A times B cross B. If we put our hand there, we wrap our hand from A to B. Our finger rotate is from A to B. Then our thumb will be facing the inside. And if we go backward from B to A, from our fingers from B to A wrap it, then our thumb will point out. So the direction will be opposite. One is inside, another one is outside. Direction is opposite, so it's a negative. If a cross times two vectors add together, we could just separate them. If it's a scalar at front, we could just move the scalar or move the scalar to the front. It doesn't matter. So now I will show you another way to memorize this cross product formula. So we could use A cross B. We are going to create a matrix. That is, instead of the 2 by 2 here, we will use 3 by 3. So 3 rows and 3 columns. So this one, we put a direction, unit vector, standard unit vector here, ijk. And for the first one, we write A1, A2, A3 here. X, Y, Z direction, and for B is B1, B2, B3. And for the cross product, for the I direction, will be just this part. So for the I direction, we cross this row out, just to have this part left. Okay, so we are going to write I, then it will give us A2, B2, A3, B3. The magnitude of this matrix. Then plus J direction. J direction we are going to write is, we cross the J out, we continue. This part with no numbers, we put A1, A2 here. So for this part, we are going to get rid of this out. Okay, so this is a J direction. We cross the J out. Then we continue to the next part. It will be this part, A3, B3, A1. This is B1, okay? So this is our matrix. So this one will be A3, B3, nothing here, we just rotate it to the next. So A1, B1. And compare this one, it's right. Then just plus K. The K, we just cross the K out. We only have this part left. So we have A1, B1. A2, B2 left. Then we have the cross product formula, okay? And when we do the cross, we find the magnitude, we use cross times this minus the diagonal, 2 diagonal minus. So A2, B3 times cross times minus another diagonal multiply. then plus J. The magnitude of this matrix is A cross times, then minus another cross. So A3B1 minus A1B3. This one could rotate. B3A1 multiplication doesn't matter, the order doesn't matter, okay? For each term doesn't matter, but the minus is must be this diagonal minus another diagonal. So K A1B2 minus A2B1, okay? So I found out this is an easier way to find the cross product. So just if looking for I direction, it's just whatever left is that matrix. For J direction, we continue. There's nothing here. We move the IJK, the I to here. So we only have A3, B3, A1, B1 here. For K direction, cross out, only this part left. This is our matrix. Okay. So now we know the how to find the product, cross product. We are going to do some examples. So this one, example 1, calculate cross product of these two vectors given. So we have A1, B1. So this is A1, A2, A3. B1, B2, B3. I don't want you to force yourself to memorize that formula. We just write it nicely in the 3 by 3 matrix. So I direction, J direction, K direction. We copy the XYZ coordinate here, -1, 2, 4. Then 3, 4, 3. So we copy the I out here, okay? Because later we may need this one to continue for the direction. So that equals I direction. We ignore the I, we just have this part. Is 2, 4, 4, 3. Then plus J direction. J direction, cross out, only 4, 3, -1, 3 left. Then plus K direction, cross K out, only this part left. -1, 3, 2, 4. Then I times, cross times, then minus other diagonal cross product. Then cross multiply, and J direction 4 times 3 minus 3 times -1. Then plus K direction -1 times 4 minus 3 times 2. Then simplify. I direction 2 times 3 is 6 minus 16 -10. Plus J direction 12 plus 3 is 15. Then plus K direction -4 minus 6 -10. So we could rewrite it as A times cross product B. We have a vector -10, 15, and -10. Then it's done. Then for the second one, so we do the A times cross product of B 3 by 3 matrix. So I, J, K. Then 2, 1, 0, -3, 6, 7. The I direction is just 1607. Cross the I out, only this part left. Then plus J. J is a little bit tricky. We need to put I continue to -3. So J cross out, it will be 07. I direction, follow it, then plus K. k is only this part, 2, 1, -3, 6. Then do the calculation. I direction will be 1 times 7 minus 6 times 0. Then plus j direction, 0 times anything give you 0, just minus 14. 2 times 7. So j direction is 0 minus 2 times 7, then plus k direction, 2 times 6 minus 1 times -3. Then do the integer multiplying, so I times 7 plus j times -14. 2 times 6 plus 3 is 15. So A cross B equals 7, -14, and 15. That is done. So this is a cross product of two vectors, and now we are going to use a cross product, another formula. This is kind of like the area of a parallelogram. So uv times sine theta. Cosine theta is for the dot product. So sine theta is height times base for the area. Okay. So we have u, we have v, then uv just cross product the magnitude equals u magnitude times v magnitude times sine angle 60 degrees, because it's a height. 4 times 10 times sine 60. Then use your calculator to find out. The answer will be 34.64. Then 2 decimal places. If the question didn't ask you, you could keep at the exact value. So it will be 20, then square root 3, exact value. So on your test, you could just keep everything to 2 decimal places. It will be easier. And after that, this one is just conceptual questions. It's just determine each expression is a scalar, not vector, or is a vector or meaningless. Meaningless. It doesn't exist. So A cross B, 2 vectors cross multiply, then we know that is AB cross, then it will be either this one AB, it will be go inside. So you put your hand there, then your finger from A to B, wrap it. Then your thumb direction is this is direction of the cross product. So this is a vector, the final answer for it. The dot product of 2 vectors will be the work, so it will be a scalar. And A cross B, this is a vector. The vector dot product with another vector give you a scalar. The dot product give you a scalar, and cross with a vector. This one, we don't have the cross product for scalar with vector, so this is meaningless. Okay, so this is a conceptual question, and the homework will be on deltamath.com 6.5. And this is a teacher created question on deltamath, so each question we don't have unlimited questions, so each question only one, so you need to be careful to only one question. If wrong, then you could ask me to reset that question, retry it, but you don't have another question to give you to practice. Thank you, and we are going to go over today's lesson, what we have covered. So we have done the dot product before, that is work, so it's just a times cosine, magnitude can give you the dot product. The final answer is a scalar. The formula is x direction times plus y direction times plus z direction times. And for the dot cross product, that is a vector. So the final answer is perpendicular to the two vectors given. And we have this part, you don't have to know it. It's just to know it. You don't have to know it. It's just derive of the formula. So from the two linear system, we could find that the ratios are equal. So x, y, z, we could write it as a k, a constant, times these three components. And if k equals 1, that is what mathematician define the cross product. And the application for that one is area of a parallelogram. So a times b sine theta give us area of the parallelogram. And here is how to memorize it. We create 3 by 3 matrix, and ijk, x direction, y direction, z direction, we write a and b vectors here. For I direction, we cross I direction out, only a2, b2, a3, b3 left. For j direction, cross j out, we have a3, b3. We move the I to the very end to make it 2 by 2 matrix. So a3, b3, a1, b1. And for the k, cross k out, only a1, b1, a2, b2 left. And for the magnitude of each matrix, it's just diagonal cross multiply. So a2, b3 minus b2, a3. So instead of memorize this formula, you can just use this 3 by 3 matrix. It's easier for you to come out with a formula. So you have to know this formula by yourself. Then we just practice on finding those cross product, and if magnitude given and the angle given, we can find the area of this parallelogram right away. And backward, if we have the magnitude, if we have the a and the b, if we have these two, we find the a cross b, then we could from here. So we didn't have this such question, but you could do it. So from here we could find the magnitude, negative 10, 15, negative 10 squared. This is a cross b magnitude. It will be equals a magnitude times b magnitude times sine theta. So this is a1, b1, a3, b3, a1 squared, a2 squared, a3 squared. B, we could find it. Then from the cross product, we could find the angle theta. Okay. So you could use this one, or you could use a dot product. Dot product will be easier. So a dot b equals a b cosine theta. So it will be easier to use a dot product to find the angle. When you have two vectors given, dot product will be way more easier than the cross product. This is just a scalar. You don't have to find the magnitude again, just scalar, then magnitude, find the angle. Okay. And also we have go through, okay, cross product, vector, dot product, scalar, and cross again times a vector will give you a scalar. If it's a scalar, cross times a vector is meaningless. We don't have such thing in our calculation. Okay, thanks for watching.